this video, we are going to look at a problem based on conservation of mechanical energy. So we have got here a tree and a house. And what's happening here is, in a storm, one of the limb of the tree, that means one of the branch of the tree, falls down and falls to the roof of the house. A 22 kg tree limb is 13.3 meter above the ground. During a tropical storm, it falls on a roof that is 6 meter above the ground. That's what our situation is. Find the kinetic energy of the limb when it reaches the roof. Assume that the air does no work on the tree limb. That's our part A. Part B, what is the limb's speed when it reaches the roof? So limb here is the branch of the tree which is falling down. So we'll get the things data which is given to us. The mass is given as 22 kg, 13.3 meter above the ground. That's there in the picture. And then we have 6 meter for the limb when it reaches the roof. So the roof is at a height of 6 meter, and that's also there in the picture. Then it's asking for kinetic energy when it reaches the roof. So what we will do is, we will label the two heights, the initial height as A and the final height as B. That means the position from where it is falling, let's take it as A, and finally where it reaches is B. Conservation of mechanical energy tells us that mechanical energy initial should be equal to mechanical energy final. So for us here, initial is A and final is B. And mechanical energy is kinetic plus potential. So here we have potential is GPE. So we can rewrite the equation in this format. Now we'll make a quick table here, a little table at point A and B. What's the speed and what's the height? This is just for us to get all the details, what's happening to energy. So it starts from zero speed, which we can see in the picture. It is also labeled VI as 0. So the speed at A is 0 and the height at A is 13.3. The speed at B we don't know. We want to find out. Basically, we don't want to find the speed at B in this part. We want to find speed of B in the next part. But basically, we don't know what is the speed at B. And the height at B is 6 meter. So we can write kinetic energy at A is 0 because the speed is 0. And then the rest of it we can have just rewritten with the formula. GP is mgh. So we just use the subscript A and B to distinguish between them. Okay, then we substitute the values which we have. And then we can find the values using calculator and get the answer for kinetic energy at point B as 1606 joules. That's our final kinetic energy at point B. That's our first part. Second part, it's asking what is the limb's speed when it reaches the roof. So now it's asking for speed. We already got kinetic energy. We want to find the speed. So we just copy kinetic energy number, the number which we got in the previous part, we copy it here. And we write the formula for kinetic energy, which is half mv square. Again, replacing the numbers, solving using our calculator, we get v square as 146. Now, sometimes students can make this mistake of leaving the answer here. It is v square, it's not the speed, it is a square of the speed. We want to find the speed, so we have to take square root. That comes out as 12.1 meter per second. I hope the video was helpful. Good luck.